Let's start off with the equation x minus 1 squared minus 49 equals 0. What are the two solutions to this equation? And if you'd like to review quadratic equations instead, click down here. Nicely done. X can equal 8 or it can equal negative 6. Next, suppose you're asked to solve this quadratic equation. 2x squared plus 4x minus 8 equals 0. How might you do this? Well, first, let's divide both sides by 2. On the right side, 0 divided by 2 is still 0. On the left side, what's 2x squared plus 4x minus 8 divided by 2? Write your answer as another quadratic. Great, so we have x squared plus 2x minus 4 equals 0. So now let's see if we can solve this equation. Well, let's add 4 to both sides so that we have just x terms on the left. Subtracting 4 and adding 4 cancel out, and on the right we have 0 plus 4, which is 4. So how can we solve this equation for x? Well, we can factor x squared plus 2x as being x times x plus 2. But what we want is to have exactly one x appearing in this equation so that we can solve for it. So let's try something a little crazy. Let's now add 1 to both sides. So on the left we have x squared plus 2x plus 1. Why would we do that? It looks like we're just making our equation more complicated. Well, try factoring this quadratic, and you'll see why we added 1 in just a minute. Excellent, so x squared plus 2x plus 1 equals x plus 1 times x plus 1. And since we're multiplying x plus 1 by itself, we can also write this product as x plus 1 squared. And so now our equation is x plus 1 squared equals 4 plus 1, or 5. Great, so now we have exactly one x in this equation. So according to this equation, what are the possible values for x plus 1? Exactly. If x plus 1 squared equals 5, then x plus 1 can equal root 5 or negative root 5. And so using these two equations, what are the two solutions to the equation x plus 1 squared equals 5? Excellent. X can equal negative 1 plus root 5 or negative 1 minus root 5. And so these are the two solutions to our original equation. 2x squared plus 4x minus 8 equals 0. You'll often see square roots in your solutions to quadratic equations, but you can also write these answers as decimals. Go ahead and round each of these solutions to 2 decimal places. Right, negative 1 plus root 5 is about 1.24, and negative 1 minus root 5 is about negative 3.24. So at this point, we're ready to solve the general quadratic equation, which we can write as ax squared plus bx plus c equals 0. So we're going to solve this equation for x in terms of the coefficients a, b, and c. A, b, and c could be anything, positive, negative, 0. It makes no difference. We're going to solve them all in one fell swoop. First, let's multiply both sides of this equation by 4a. So on the left, we're distributing the 4a. 4a times ax squared is 4a squared x squared. 4a times bx is 4abx. And 4a times c is 4ac. On the right, 0 times 4a is just 0. Okay, so now let's see if we can solve this equation, which looks pretty messy. Let's have just the x terms on the left side, so we'll subtract 4ac from both sides. So these terms cancel out, and we have negative 4ac on the right side. So now what? Well, we have an x squared term and an x term up here. Let's see if we can rewrite this expression with exactly one x. The trick is to square this binomial, 2ax plus b. So we're multiplying 2ax plus b by another 2ax plus b. Let's use FOIL. The first terms are 2ax times 2ax, or 4a squared x squared. The outside terms are 2ax times b, or 2abx. The inside terms are b times 2ax, or 2abx. And the last terms are b times b, or b squared. Ooh, that's a lot of variables. Now, if you look closely at these four terms here, which two of them are like terms that we can combine? Exactly. 2abx plus another 2abx is 4abx. So 2ax plus b squared equals this expression. Finally, let's subtract b squared from both sides. So these terms cancel out, and on the left we have 2ax plus b squared minus b squared. Aha! Notice that this expression on the right is exactly the same as the expression up here. So we can replace 4a squared x squared plus 4abx, an expression that contains both x squared and x terms, with 2ax plus b squared minus b squared, an expression that contains exactly one x. So to solve for this x, let's add b squared to both sides. These terms cancel out, and on the right we have b squared minus 4ac. So in this equation here, what are the possible values for 2ax plus b? Right, so 2ax plus b can equal the square root of b squared minus 4ac, or the negative root of b squared minus 4ac. And remember, you can combine these positive and negative expressions into one answer. 2ax plus b equals plus or minus the square root of b squared minus 4ac. So we started off with the general quadratic equation, ax squared plus bx plus c equals 0, and now we've almost solved for x. Let's subtract b from both sides. So these terms cancel, and on the right we have negative b plus or minus the square root. And finally, let's divide both sides by 2a. On the left, the 2a's cancel out. And we've done it. So for any quadratic equation of the form ax squared plus bx plus c equals 0, you know that x must be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is known as the quadratic formula. Proving this formula was a lot of work. Don't worry about rederiving it. You're better off just memorizing it and knowing how to use it. So let's look at another quadratic equation. X squared plus 3x minus 2 equals 0. Let's find the solutions using the quadratic formula. So a good first step is to identify the three coefficients, a, b, and c, for this quadratic. What are they? And keep in mind that one of them is negative. Right, a is 1, b is 3, and c is negative 2. So to find the solutions for this quadratic equation, let's plug these three coefficients into the quadratic formula. We can plug in 3 for this b as well as this b. Let's plug in 1 for a and negative 2 for c. And in the denominator, we'll plug in 1 for a. Yikes! Let's see if we can simplify this a little. We've got negative 3 plus or minus a square root. Inside the root, we have 3 squared, or 9. Now, 4 times 1 times negative 2 is negative 8, and we're subtracting negative 8, which is the same as adding 8. And the denominator is 2 times 1, or 2. Under the root, we have 9 plus 8, or 17. So here are the solutions. Negative 3 plus or minus root 17 all over 2. So then one of the solutions is negative 3 plus root 17 over 2. Try writing this solution as a decimal, rounded to 2 decimal places. Excellent! So one of the solutions is approximately 0.56. To find the other solution, you'd have a minus sign in front of the square root, and this is approximately negative 3.56. So by plugging the coefficients into the quadratic formula, we found the two solutions to this equation. Try finding the solutions to one more quadratic equation. 3x squared minus 5x plus 1 equals 0. Round your answers to 2 decimal places and feel free to ask for a hint if you get stuck. Brilliant! So one solution is 5 plus the square root of 13 all over 6, and the other solution is 5 minus the square root of 13 all over 6. This first solution is approximately 1.43, while the second solution is approximately 0.23. Again, nicely done. For any quadratic equation, ax squared plus bx plus c equals 0, the quadratic formula tells you the solutions. X equals negative b plus or minus a square root all over 2a. What's the missing expression under the square root? And click down here if you'd like to review. Exactly, so the quadratic formula says that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So try using the quadratic formula to find one of the solutions to this quadratic equation, x squared minus 2x minus 1 equals 0. Excellent, so the two solutions to this quadratic are 1 plus or minus the square root of 2. Values of x like these, where a polynomial equals 0, are also known as the roots of the polynomial. Next, let's see what this means graphically. So here's the graph for y equals x squared minus 2x minus 1, the quadratic whose roots you just found. Now to find the roots, you set the quadratic equal to 0. In other words, to find the roots, you can set y equal to 0. Does setting y equal to 0 and then solving for x sound familiar? So are the roots the same thing as this graph's x-intercepts or the y-intercepts? Exactly, so the roots of a polynomial are the same thing as the x-intercepts of its graph. Pretty cool, right? So next, try making a quadratic graph with no roots. You can drag these sliders down here to change the coefficients in the quadratic. Once you've got a graph with no roots, press the Submit button over here. Nicely done. So here's another example of a quadratic polynomial with no roots. 2x squared plus 2x plus 1. But wait a second, can't we use the quadratic formula to find the roots? What does it mean when a quadratic has no roots? So we're looking at the quadratic equation 2x squared plus 2x plus 1 equals 0. The graph for this quadratic has no roots. Does the quadratic formula agree? Let's find out. Now the part of the formula that's under the square root, b squared minus 4ac, gets a special name. It's called the discriminant of the quadratic. So for this quadratic that apparently has no roots, what's the discriminant? Right, for this polynomial, b squared minus 4ac equals negative 4. So the quadratic formula is telling us to compute the square root of negative 4. What's this square root, or does it not exist? Right, negative 4, just like any negative number, doesn't have a real square root. So in general, whenever a quadratic has a discriminant that's negative, it has no roots. So you don't even have to graph this polynomial. If b squared minus 4ac is negative, you know immediately that it has no x-intercepts. Okay, with the discriminant, you can immediately tell when a quadratic has no roots. Next, try making a quadratic with exactly one root. So you want a quadratic with exactly one x-intercept. Once you've got one, press the Submit button over here. Great, so here's another example of a quadratic with exactly one root. The quadratic is x squared minus 4x plus 4, and it looks like its root is 2. Let's see what the quadratic formula has to say about this one. Okay, so remember that the discriminant is b squared minus 4ac, and we were just looking at the quadratic x squared minus 4x plus 4. So, what's the discriminant for this quadratic? Exactly right. For this quadratic, b squared minus 4ac equals 0, and the square root of 0 is just 0. Now a cool thing about 0 is that if you add 0 or subtract 0, either way you get the same result. So we can actually just ignore the whole plus or minus square root part of the quadratic formula, and that's why there's only one solution, and it happens to equal negative b over 2a. So, go ahead and use this formula to compute the one root of this quadratic. Right, negative b over 2a equals 2, so the one root of this quadratic is 2. And that's precisely what you saw in the graph. There's exactly one root at x equals 2. So, here's the quadratic formula, and the discriminant is b squared minus 4ac. Are you ready to come up with the general rules? When a quadratic has a negative discriminant, how many roots does it have? What about when the discriminant is 0? Does this plus or minus sign matter? And what about when the discriminant is positive? Brilliant! So just by calculating a quadratic's discriminant, b squared minus 4ac, you can immediately tell if it has 0 roots, 1 root, or 2 roots. And these are the only 3 possibilities. Okay, let's finish this lesson with a real-world example. Suppose you're standing on a building over here, and let's say this building is 5 meters tall, and you throw a ball up in the air at 10 meters per second. Now, if you've ever thrown something, you know that what goes up must come down, and the ball follows a path or trajectory like this, which looks suspiciously like a parabola. Well, it is a parabola. So a classic question in physics is, how far away from the building does the ball hit the ground? Using the laws of physics, which you can learn in a physics course, you might figure out that at a distance x away from the building, if the height of the ball above the ground is y, then for this building and initial speed, y equals negative 1/10 x squared plus x plus 5. So this is the equation for the parabola. Now when the ball hits the ground over here, that's when the height, or y, equals 0. So let's replace the y here with a 0. So then how far from the building does the ball land? Can you solve this equation for x using the quadratic formula? And be sure to round your answer to at least 2 decimal places. Precisely, so the ball will travel 13.66 meters. And like any quadratic with a positive discriminant, this equation has 2 solutions, the other being negative 3.66 meters. But in solving this question, you can reject that solution. That's equivalent to the ball moving backwards. So nicely done. At this point, you can use the discriminant to determine how many roots a quadratic will have, and you've used the quadratic formula to solve a real-world problem. Excellent work!